Let's have a look now at example 2. And our vessel length between perpendiculars 150 metres. Work drafts 4.82, 4.56 aft, 4.82 forward. And we're in water of relative density 1.010. We need to calculate the amount of cargo still to be loaded if our load draft is 6.46 in salt water. So in this problem, initially we're in water of density 1010, but we need to be loaded so that when we're in salt water, our draft is 6.46. Calculate the cargo to load, still to be loaded. It's a case of finding our initial true mean draft and looking up the displacement in that density of water, and then looking up our final draft of 6.46 in salt water to get the displacement salt water, and subtracted one from the other. So we'll deal with 6.46 first, and all we need to do by interpolation is find the final displacement as 6.46 in salt water, and if you go into your tables, the displacement falls between 13,201 and 13,429. We do the simple sum for our interpolation, and we find that our final displacement is going to be 13,338. Okay, so let's find our initial displacement. Now, got to be careful here because our density is 1.010. So first of all, we find our average approximate true mean draft, or average mean draft, 4.69. We go into the tables at 4.69 and we get the LCF, and we find that it's 69.36. So by interpolation, at 4.69 of a metre, and the interpolation is on this side here and here, we find that the LCF is 69.36. As you can see, LCF doesn't matter what density water we're in, we've just got the one value to use. Get our total trim, difference between the two drafts, and you'll notice with this one that our forward draft is 4.82 and aft is 4.56, so we're actually trimmed by the head. So when we use the formula true mean draft, then it's the aft draft plus the difference, because we're trimmed by the head. Our aft draft is less than the forward draft, so as we moved from aft to forward, the draft must increase. So we find our true mean draft is 4.68. Now to find the displacement of this in this density 1.010, we must find the volume of displacement. All that is, it's the same numerically as the freshwater value. Because density in freshwater is 1, density is mass over volume, then mass and volume must be the same value because freshwater density is 1. So we go into the freshwater tables to get our volume of displacement, and we find that it's 9148 by interpolation at 4.68. Therefore our initial displacement, which must be volume times density, gives us 9148 times 1.010, 9239. So our initial displacement is 9239. So we've got the freshwater value, which is the underwater volume, multiplied it by the density, that gives us our displacement. Then, like the previous problem, now we've got two displacement values, one our final displacement, one our present displacement. Subtract one from the other, and that's the cargo to load 4099.